Okay, so the first couple of questions are on whether a relation is a function. Now, from class, you will remember that we talked about relations is just some way to relate one number to another, or a name to a number, something to something else, really. It could be anything to anything. So, for example, we could say 3 comma 4 is a relation, right? And we would need to know more information to see if it's a function. We also talked about maybe it could say apples and 5. So the relationship there might be apples. There's 5 apples in a basket, maybe. You could see maybe the year, 19, let's say 98, comma, and then maybe how many hurricanes there were in that year, right? Okay, I'm just making up numbers there. I don't know. So when is a relation? When does it become a function? For the most part, you've always heard that the x cannot repeat, right? So if you have a table and in the table you see a list of numbers. So for example, if I say 1998, there was 8 hurricanes. In 1999, there was 11 hurricanes. And then I tell you, 1998, there was 7 hurricanes. Well, the first thing you're going to say is like, wait a minute, you're lying to me because you already told me there was 8, right? How is there going to be 7 now in that same year? So if the x repeats, then this is not a function. And the reason we need functions is to make sure that when we're working out situations, calculating things, that we're consistently getting the same answers, right? We always have to get the same answer. So if this was an input of 1998, the output should always be 8, or it should be 7, but it can't be both. It's got to be one or the other. So that's why we need functions. So that's one way to do it with tables. Another way that you might see it is as mappings. So you have two ovals and x and y, and the same example would be something like this: 1998 would go to 8, right? But then at the same time, we have that 1998 is also going to 7, right? So that's when you have an issue there. So when you see this happening from one number to two different numbers on this side, that is not. So this is not a function. Not. Right? Because I'm lying to you, right? Basically. Uh, if you see it this way, where 1998 oops, goes to 8, and then 1999 also goes to 8, that's okay, right? In this case, it's basically the y value is being repeated, right? So it would look something, if it was a table, you have 1998, it goes to 8, and then 1999, 99 also goes to 8, right? So that's okay. The y, this value here can come out more than once, right? And if you were to graph it, let's say this is 1998. Sorry, backwards, not that way, the other way. If this is 1998, right? You have 8, and then this is 1999. You also have 8. So that's okay. It can look like that. Now that we're on the topic of graphs, how can you tell if a graph is not a function? We use what we call the vertical line test, right? So if I have a graph, if I have a graph and it looks, let's say, like a circle, will this pass the vertical line test? Well, if I can draw a line and it hits the graph, it should be directly above itself. If it hits the graph twice, then no, it is not this is not a function. So this is not a function. Uh, Now, if I can draw a line and I only hit it once, so like here, it only hits once there, it only hits once there because it's just points. So then yes, that is a function, right? Yes, it's a function. So no need to worry there. So one of the ones we usually see, ooh, that was a bad attempt at a line. If we see, let's say, a linear function. This is always a function, linear function, right? Because it's no matter where you draw the line, the vertical line, you're only going to hit it once. So that's good. Now, if you have a parabola, quadratic, right, something like this, then this is always also a function. So x to the y equals x squared. This is the parent function. This is not the parent graph, but that's the parent function. If I were to draw a straight vertical line, I'm only going to hit it once, right? X cubed. That one looks like this. That's also going to be a function. So what is a graph that does not is not a is not a function? So one of them is if you were to have uh, y squared equals x. So, and we talked about this one in class. This one is a sideways parabola. It gets rotated 90 degrees to clockwise. So if I to draw a vertical line, I'm going to hit it twice. So this is not a function. So that's the vertical line test. Okay. Now the other one you might see is if you see as points, just a list of numbers. So if they tell you the function f is equal to, and then they give you a list of numbers, 2 comma 3 comma 3 comma 4 comma. Just make sure that the x does not repeat. All right. So if I have, let's say, 5 comma 7 and that's it, then yes, that's a function. Right. That's a function. Yes. So the x's don't repeat. So it's very similar to if it were a table. So what would it look like if it wasn't a function? Then I'm going to have a point that has the x come out twice. So, and then something like that with a different y. Right. So you see that this 2 comes out twice and these numbers are different. So not a function. Okay, so that's how you can tell if a relation is a function or not.